Hello class, it's Mr. Wicklehouse, and today we're talking about graphing functions. And the particular function that we're going to be talking about today is the radical function. So this is the end of the radical unit. We got to learn how to graph these things by hand. Alright, let's get this going. Alright, so what's a function? So a function is a mathematical relationship between an input and an output represented as f of x, or it could be g of x, or h of x, or whatever. We've talked about that before. When we graph functions, we can use a base function called the parent function. Okay, we're going to be talking a lot about parent functions when we're talking about graphing for the rest of the year and stuff, and what the other types of functions that we'll have. And then what happens is we apply transformations to this. Okay, so I don't know how much you remember of transformations in geometry, but that's basically what we're doing here. Okay, so the parent function for this unit that we will use is, of course, the square root of x. Okay, we've been talking about simplifying radicals and doing all sorts of stuff like that this unit. So we're going to use the square root of x. And when we apply the transformations to the parent function, the function changes to look like this. So instead of f of x, then it's going to be a times the function x minus b plus c. So that this part a right here is a combination of dilations and reflections. So if it's a positive or a negative, it'll be reflection, and the number that's out here will make it bigger or smaller based upon what that number is. Okay, this B part is a horizontal translation. In other words, it's moving it right or left. So this moves it right or left. And then C, this part right here, is the vertical translation that will move it up and down. So the way this looks with our parent function is like this. So this will multiply by our function, and it will make it bigger, smaller, stretched out, or contracted. This will move it right and left. This part will move it up and down. Okay. That being said, let's just dive right in and learn how to graph these things. Okay. So, we're going to start off graphing the parent function. And when we're graphing these things now, you can make t-tables and whatever if you want to be exact and perfect, but we're not going to worry about doing that. All we're trying to do, a lot of times when we're graphing these things, is get an idea of what these graphs look like. So, making them exactly perfect doesn't really help anything. We can graph these things just by using a couple of points. And the first point for this parent function that I'm going to use is going to be the origin, so 0. So when I plug 0 into x, I get 0, so y equals 0. So this, right there, smack in the middle, is where my function is going to start. Okay? That being said, if I plug a 1 into here, I'm going to get 1 again, and that's another point in my function. After that, though, I don't really care. If you could get the idea of what this looks like, that is ultimately what I am most concerned about. And these functions just look like you're taking this and it's curving up and around, just like that. That is our parent function. It looks just like that. It's a slow curve. It's increasing very slowly. Okay? So that's basically what we're going to start with. So the other thing that we need to talk about with these graphs of these functions is domain and range. So remember that the domain are the numbers that I'm plugging into my equation or into my function that is going to give me an answer of some sort. Okay. Well, for the square roots, I can't have any negative answers under here. So my domain for this particular function is going to start at 0, and it's going to increase from left to right forever and ever, so it's going to infinity. So there is my domain for my function. Remember, the range is the output of my function. So it's how far up and down I'm going. So again, this range for this parent function is going to start at 0. And although it is increasing very slowly and going to infinity very slowly, it's still going up forever. Forever and ever it's going to be increasing. So it's going to a positive infinity there. Okay. So there is my range for my function. Okay. Easy, easy peasy on that. Alright. Now let's add a translation to this. So remember, we're using this transformation where A is a dilation or a stretch or whatever, or a reflection. This moves it left and right, and the C moves it up and down. Well, I'm looking at this one, and I can see without anything that there's my parent function. I just take the numbers out and imagine what my parent function is, and my parent function is this square root of x function. It looks just like that. Well, then I look at this plus 3. So I'm wondering, is that the A, the B, or the C? Well, it's not underneath the square root with the x. It's not being multiplied out here in front. So it is the C value. So this piece right here is going to move us up or down. Well, since it's plus 3, it's going to move us up 3. So I look back here at my parent function, and I start at this 0, 0 spot, and all I'm doing is I'm picking this whole picture up, and I'm moving all these points up 3 spaces. So this 0, 0 goes 1, 2, 3, right there. And if you remember, we also graphed this point 1, 1. Well, the 1, 1, I start there, and that's going to move up 1, 2, 3 as well. And every point, so let's graph the parent function on here. I'm just going to do it with a dashed line this time, so you can see how it changes. So there's my parent function. This is f of x equals the square root of x. And all of these points that are on this line are just moving up 3. So this now is f of x equals the square root of x plus 3. It just moved up. Okay? So that's all I would do. Another thing you could do, if you're unsure about what that looks like, you could come in here into your handy dandy calculator, go to the y equals, Is it going to go into focus? Okay, we're good. And we'll just enter our function in. So second square root x, come out from underneath of my radical, plus 3, graph. There it is. And we can see that this looks very similar to that. Okay? So that's another way that you could self-check yourself. Might help a little bit. Let's look at another one. Okay. This one's written a little bit differently than what this is up here. Than what this is. So we've got this. Remember, we're using this, a times square root x minus b plus c. Okay. So here's my parent function again. Get that graphed on there just so to help us think about it. Okay. So I'm going to rewrite this just so it looks a little bit more like this, and so hopefully it won't be too confusing for you. And just know that you can do this, okay, if it helps you. So here's the main part of my function, the square root of x. And I'm going to leave everything underneath of there. I don't have a number here in front that I'm multiplying, but I am adding negative 4 to it. Well, adding negative 4 out front like this is going to be the same as subtracting 4 here at the end. So adding negative 4 and subtracting 4, they're the same thing. So what I'm going to do now is I'm going to take each piece of my function and I'm going to break it down so that I can see exactly what's going on. And I'm going to start out with this piece underneath it here. Okay, so the next part, so I graphed this. This is f of x equals the square root of x. That's the function that I just graphed. Now I want to do the transformation, and I'm going to do it so that the square root of x plus 3. Now you might be looking at this and saying to yourself, this is going to move to the right 3. But look, right here, see how this says minus b? Well, a negative and a negative makes a positive, so really this is the same as square root of x minus negative 3. So my transformation here is actually a negative 3, so it's going to move to the left 3. Everything's moving to the left. And I'm going to do this one in a dashed line as well. And that's that function. So when it's positive here, it moves it to the left. If it was negative, it would move it to the right. So that's something that you need to keep in mind. Underneath, with the function, positive means left, negative means right. Okay? Alright. I've got this part transformed. Now let's do the last part. We'll do the square root of x plus 3 minus 4. So I'm coming over here to where I've transformed this one, and I'm going to move everything down 4 spots now. So I'm going to this, and I'm going to go 1, 2, 3, 4, right there. There's that one with the 1, 1, 2, 3, 4. Now I'm just going to graph it. And there we go. There's our function. There's the one we were trying to graph right there. Okay. So just take it in pieces And if you take it in pieces, it'll make it a little easier on you. Okay? Alright. Let's do one more, and then this video will be done. I know this video is kind of excessive, but I wanted to make sure I went slow so that we could understand each piece of the transformations as they're happening. Okay, I'm going to rewrite this one again. I'm going to rewrite this as f of x equals 2 times x plus 4 minus 5. Okay. Now, let's get this show on the road. Alright. First thing I'm going to deal with is this 2. Okay, so I'm going to graph, well, I guess I'll graph this function first, the parent function. Okay. So there's our familiar parent function. We put them in each one. Now I'm going to add the 2 to this. Okay. All this is doing is multiplying each piece of this by 2. So the 0 is going to stay where it is, but the 1 is going to be here at 2. So now you can see that this thing is just getting taller. Getting much taller. It's been stretched up a bit. It's widened out quite a bit. Okay, that's all this number does. Again, you can always graph it if you're unsure, and do the graph in your calculator, and that'll kind of help you along the way too. Alright. Now I'm going to do this piece. Again, don't let this fool you because it's plus 4. Don't think that you're moving to the right. We're actually moving everything to the left 4. So 1, 2, 3, 4 is now my starting spot. This one that it's at 2. 1, 2, 3, 4. This is the next spot, and so on. So now this is going to look more like that. Okay. And my final transformation is here with the -5. So I'm here, and I'm taking this and I'm going down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there is my final transformation, and that graph is going to look something like that. There we are. Okay? That's all I'm going to do with you today. For God's sake, Mr. Wicklehouse, will you shut up? This is an 19 minute video almost. I'm so glad that you're done talking. I'm done talking for now, and I'll talk to you later.